Hi folks, we're going to take a look at number 15 on page 300. So they give us these two vectors, x and y, and they tell us they're unit vectors. So the first thing to recognize is what this means, and a unit vector just means a vector that has length 1. Now this textbook here does not use the hat notation, which I've introduced to you. So you might see me use the hat notation, you will recognize as it being a unit vector. Here they just tell unit vector, so you know magnitude of 1. And it says that it's got an angle of 30 degrees. They make an angle of 30 degrees with each other. And this is where, again, you have to recognize what this means. It means that if you place the vectors tail to tail, the angle between them is 30 degrees. So if I were to draw these two vectors, well, I'd have my vector, say, x here, and my vector y. And they have an angle of 30 degrees between them. Okay, so it's understood that when we say the angle that they make with each other, the angle between them, they have to be placed tail to tail. Okay, however, we're not looking for the operation between x and y. We're looking for an operation between 2x and y. So all that means, remember that this is just scalar multiplication. So, excuse me, if the magnitude of x is 1, the only difference this 2 makes is it's going to be in the exact same direction except with a magnitude of 2. Okay, so this is what I'm going to draw. Now, it's an odd way of asking the question. They specifically ask for the magnitude of this vector and then the direction of this vector. If they had just asked, find the vector 2x plus y, it would be assumed, since that gives us a vector, it's assumed that you would be stating both the magnitude and direction. Here they're just asking for it individually. Okay, so I'll start by drawing a picture, and I'll draw it a little bigger here. So let's say this is my angle x, and my angle 2x, because that's the one I'm actually working with. So because x was a unit vector, that has magnitude of 2. And then here, this will be my vector y, make it about half as long. Okay, and the vector y, okay, this magnitude, it's a unit vector, so it's equal to 1. And the angle between them is 30 degrees. Okay, now what I want to do is add these two vectors. So best way to do that is to just slide this one over and draw it tip to tail to the first one. Okay, and of course, as we know, it's going to give us this vector here from the tail of the first to the tip of the second, or the diagonal of the parallelogram formed by the two vectors. Problem is, as we've seen before, is this angle 30 that was given to me is not actually inside this triangle. Okay, I have to use an angle inside this triangle, and it's going to be this angle here. That since this vector, when I move it to this side here, is still going to be parallel, I can use my parallel line principle. So this is just going to be the supplementary angle to 30. So 180 minus 30, this is just going to be 150. Okay, and now I can solve my problem here using trigonometry. So this here is going to have magnitude of 2. So I'll start by using the cosine law. So for the magnitude, it's going to be the magnitude of 2x plus y is equal to, and now I'm just going to apply the cosine law. So the square root of, so the square of the other two sides that are not opposite the 150, all right? So that's just 1 squared plus 2 squared minus 2 times 1 times 2 times the cosine of the angle opposite the side I'm looking for, so 150 degrees. Okay, now you'll notice that I always write out the cosine law completely. Okay, and I just do this just so I'm doing it automatically. I don't have to think about squaring it first. Maybe when I put it into my calculator, I'll save some time by not putting 1 squared. But I would strongly suggest that you always write this out the same way each time. All right, so let's get our calculator here. And so we've got the square root of 1 plus 4 minus 2 times cos of 150. Okay, and let me check. Yeah, calculators in degrees. And so here we get 2.91. All right, so our magnitude is approximately 2.91. All right. Now I have to find the direction of this vector, okay? But the original vectors weren't given with specified directions. We only had an angle between them. So when I give the direction of this new vector, I'm going to give it relative to one of my two original vectors. So since I'd like to use an angle inside this triangle as much as I could, I'm going to call this angle here, should have made my diagram a little bigger, I'm going to call that angle there theta, because that's the angle that my resultant makes with the angle y. So that's what I'm going to use to describe my direction. Okay. Now, while I can use the sine law, my suggestion is to always use the cosine law when you have that opportunity, so that you don't have to worry about the old ambiguous case. It's actually not an issue here because we're working with an obtuse angle. Okay, there aren't two solutions with the obtuse angle, but I just don't take a chance. Anytime I can use the cosine law, that's always my preference. So cos inverse of, so the opposite side to theta is 2, so that's the one that comes first. So 2 squared minus the square of the other two sides, so minus 1 squared minus 2.91 squared, all over negative 2 times these two other sides, 1 and 2.91. Okay, and you see what I do is I have this little conversation in my head as to how I solve using the cosine law. So I try to avoid making any silly mistakes. All right, so let's put this in here. So cos inverse, open up the bracket for the numerator. So that's 4 minus 1 minus 2.91 squared. Okay, close bracket, divided by, open bracket, negative 2 times 1 times 2.91. Close up the brackets, and it looks like we have 20 degrees. Okay. All right, so here, let's go 20 degrees. And so how are we going to describe this? Well, I'm going to say I'm starting at y, and I'm going 20 degrees toward my vector 2x. But since my vector 2x is in the same direction as the vector x, I'm just going to say here that my direction is 20 degrees from vector y to vector x. Okay, so just to recap, number 1, recognize that a unit vector means magnitude 1. Recognize that when they give you the angle between two vectors, it's assumed that they're placed tail to tail. All right, recognize that I'm not working with x and y, but 2x and y, so all that does is it takes vector x and makes it twice as long. And careful when you're solving an addition with the vectors placed tail to tail, that when you add them, when you move this vector over, make sure you're working with the angle that's inside the triangle. Okay, that's it for this one.